I'm Sterling Colgate. I'm a physicist at Los Alamos National Laboratory and at New Mexico Tech here.
I'm Dave Westfall. I'm a physicist at New Mexico Tech.
Both of us have essentially no medical background to be talking about a medical question.
This is a physics demonstration.
What one would like to know is the effectiveness of face masks and how often they can be used in the limitation of in the case of a pandemic flu. We have here 4 kinds of face masks. Some of them are N95 certified, some are not. And we intend to rinse them in Clorox solution, which the CDC has claimed is a highly sufficient disinfectant. We have these divided up into where we will rinse them once, 4 times, 16 times, and 64, with drying them in between each time. Then the drying itself leaves the Clorox in contact with the virus for long enough to really ensure disinfecting. When they are dry, then this process will be repeated 1 time here, 4 times here, 16 times here, and 64 times. And then we will compare them with a fluorescent dye later to evaluate the effectiveness of 64 uses versus none. And 1% Clorox is roughly 2.5 tablespoons per gallon. There's a gallon of water in there. And this is what you would do to save yourself in the event of a pandemic. You, your family, your loved ones. And we'll each take one from this row and put it in. And this is essentially what you need to do for each one. Just the fact that it is drying, when they're down in the solution, you want to just crinkle them a little bit when they're down in here. Not enough to break the fabric, but just enough to ensure that the solution gets down deep. And this is what you would do in the case of a pandemic for multiple use of face masks.
To test the effectiveness of washing and reusing face masks, we've put some fluorescent dye in the water of an ultrasonic vaporizer. The vaporizer makes water droplets smaller than those produced by a cough or sneeze and produces many more. The dye in the droplets glows when illuminated with an ultraviolet light, indicating the presence of droplets from the vaporizer. We test how effectively the masks trap droplets by wearing 2 of them and showing that the first mask traps all of the droplets.
We use 2 face masks. One, presumably the outside one, collects the infectious droplets. The second face mask I have on here is to see whether any gets through the first face mask. And that's the equivalent brightness of breathing in something like 10,000 times more droplets than come across with a typical cough or sneeze. And now I'm going to expose the inside one and see whether anything has come through on it. Well, we see a little bit around the edges where I didn't seal it properly, but the main infection has been certainly stopped. I mean, the main droplets have been stopped by the front mask. And one can see that this one is really quite yellow. I take it off. And the one below presumably is not yellow. Or at least by the ratio, it's very close to being clean.
My outer mask was washed 40 times. You can see it's yellow. Here's the mask I wore underneath. So we've demonstrated that even after 40 washings, that mask continues to work. One more demonstration requires no explanation. This has been a physics experiment about the multiple reuse of face masks. We have shown that droplets that can carry virus are stopped by a mask even after multiple disinfectant washings. We have not demonstrated that virus is actually stopped. Our work brings up some questions for future funded research. What percentage of flu infections is caused by pneumonic drops carrying virus, and what fraction is caused by virus alone from dried droplets? What fraction of active virus passes through a new or washed mask even when water droplets are stopped? What fraction of infections is caused by manual contact?